Welcome to lecture 40, templates and generics. So far we had seen the template functions, template classes in C++ and generics in Java, and in the last class I introduced in Python also we have the generics. So when we look at the simple code, right, the Python, in fact the last lecture I had executed few programs, if you recall. All right, so on the continuation, so suppose assume that you have a conditional statement, in C++ and Java, you know very well, it is similar, right? It is similar to Java or C++. So slightly you can see some syntax changes, right? So here you go, suppose you want to use the conditional statements, right? Assume that x is equal to 5. If x greater than 0, you are going to print it is positive. We use else if. So here like else if is ELIF, right? X equal to 0, else if equivalent, x double equal to 0, that means if it is equal to 0, print 0, otherwise else print negative. Okay. So the syntax very similar to C++ or Java you had seen, right. So if you practice, Python will be nothing for the initial part of the code, and then when you are going deep into Python, I mean since you know the complete syntax of Java and C++, it won't be very difficult. Okay. So this is one case, conditional statement. So if I execute this code, right, since x is equal to 5, right, if x greater than 0, which is true, therefore positive is getting printed. Another thing, you want to use a loop, right. In the case of loop, for example here, for I in range of 5, print I. So the index here is starting from 0, right. It is equivalent to, for I is equal to 0, I less than 5, I plus plus, right, and then C out I, right. I will write the equivalent code because you are all familiar with C++. For I is equal to int, and assume that I have declared int I is equal to 0, I less than 5, I plus plus, right, C out I. So you know what you will get, you will get 0, 1, 2, 3, 4. Similarly here, so when I write this in Python, for I in range of 5, print I, all right. So now since you know this, so we will be getting 0, 1, 2, 3, 4, right. So this is the basic structure, you can practice. I mean till the loop, I mean it won't be very difficult. So just take the interpreter, whatever interpreter you like. In fact, last lecture I introduced, and today in fact we can see with the help of command prompts. So like Java and C++, so this is also an object oriented programming, right. Python is also OOP. So we have to know the basic syntax of the classes and objects, right. So for example, in this code you are seeing class person followed by colon, whereas in Java and C++ we see followed by the begin, right, the begin operator like the curly braces, right. So here we go with colon, and then here you have double underscore init, right, and then again double underscore. So this is a special member function, exactly like a constructor, right. So that we had seen in either Java or C++. And then you have the instance variable self, like this pointer in C++ or Java, all right. And then you have, let us say, 2 arguments you are passing, all right. So I have 2 parameters, and then we have several times we have studied this dot name equal to name in Java. So here self dot name equal to name and self dot age is equal to age, and then you have a member function, right. So here you have a member function, you are defining greet, all right. So this self pointer is going, that this I can pass always this, and then here you are having, because self I am passing because I have to use self dot name, right. Hello, my name is self dot name. Just recall what we have studied in Java. I mean maybe here and there we have to change the syntax, otherwise both look almost same, all right. And then you are having an object, let us say person is object, all right, and here you have the parameters passing alias and 30, all right. You are passing alias and 30. So once you are passing, right, so what will happen? So this is like, as I said, this is like a constructor, right. In fact, it is a special member function. So name is alias, right. So name will be assigned to self dot name, age will be assigned to self dot age, right. So that will be returned to your P, right. So that will be returned, that is what you are writing, right. So that will be returned to your P. And the next line, object P, right, which is returning means this is object, right. So in fact, self dot name is alias and self dot age is 30, right. So this object P is invoking greet. So, when it is invoking greet, it will print hello, my name is, self dot name is Alice, alright. So, I am not printing any age. So, when I run the code, maybe this code what we can do, we can run it in command prompt, okay. So, just we will go to command prompt, alright. So, in the command prompt, if I run this particular code, so this is a command python 3, the name of the file, yeah. So, person underscore class dot py. So, this file has been stored as person underscore class dot py, alright. So, when I run the code, I am getting hello, my name is Alice, right. So, this is what we have expected. In fact, when we go to the slide, so this will be your output, right. This is what exactly we have seen. So, now generics in Python. So, like the functions and classes we had seen in C++, template class, template function, or generic class, generic methods in Java. In a similar way, so here with the help of Python, when I am talking about generics in Python, so this is having, right, the flexible types. So, suppose I use T, right, or K or V, you can see here the generic types list, dictionary, right. I am using T, K, V, right. So, dictionary may be integer, float, list, but let us say character array T, right, and then we are going to have tuple, right. So, these are all the common generic types, right, in Python. So, in fact, so we can use the typing module, this we are going to use it, right. So, this typing module is allowing for more explicit type declaration. So, you can also have user defined generic types, right. So, the common built-in list, dictionary, keyword is DICT and tuple, right. So, these are all the generics in Python. So, in fact, how we are going to write from typing, this is what I said, right. So, the typing module. So, generics in Python which is relying on the typing module, and then we are going to have the explicit type declaration. So, here suppose I want to write, so that is typing import list and type variable, and type variable we are going to use T. So, this T, for example, I am creating an array, right. So, I have an array, alright. So, here in Python the return type T, this is called the return type T, and it is returning the first element. This is a simple example, right, and it is returning the first element. So, just recall how do you write the same code in C++. You put T first and first underscore element, and then you are passing an array, right. You put T, list of T, right. So, or list of T, whatever be the return type, then you are writing return. So, here I mean more or less, I mean you can understand, if you practice it is not very difficult. So, the list of T, that array will be that base address, right, that is what I am talking in terms of C++, right, the equivalent. So, if I write like this, so the base address LST, right, and then if I put LST of 0, so that means it will have LST 0, LST 1, LST 2, etc. Or in the case of C++, if I simply print LST, it will print all the elements, right. So, here if I put LST of 0, the first element will be printed. So, that you are returning, that is what exactly this program is doing. So, the main important point is, if you look at the typing, all right. So, the typing module, and you are explicitly you are going to use, or you call it as a generic type variable, the T is a generic type variable, right. We will see an example how we can use this. So, for example, up to this I have told whatever we have done in the previous slide, and the usage point of view, assume that I have a integer list, int underscore list equal to 1, 2, 3, right, and string underscore list apple, banana, cherry. So, now print, right. So, what you are doing, print, you are calling get first element, right. So, this is what we defined. Here I have defined first element, first underscore element. So, here is a generic function. This is an example of a generic function, right. Get underscore first element. Why I am calling generic function? I am using T, and return type is also T, right. So, when I am calling this function get underscore first underscore element, and I am passing int underscore list, right. So, assume that I am passing the base address of this, correct. So, when it goes here, so you are passing 1, 2, 3. Now, T is nothing but integer list, capital T is a integer list, correct. So, it has 1, 2, 3, and then it is going integer. Once it is becoming T is integer, this is also integer. It is going to return in fact integer. And what you are returning? Return list 0. That means integer list 0, index 0. Index 0 is what? 1, correct. So, 1 will be the output. The first case I will write here, we will see. And similarly, next one, it is becoming string list, character array, right? This is 0, string 1, string 2, right? So, in fact, string array, I said character array, string array, string 0, string 1 and string 2, right? So, you are passing this and get underscore first underscore element. Now, the list will be nothing but string underscore list, exactly like what we have done in template in C++ or generics in Java, right? Now, this T, capital T is nothing but string underscore list, right? So, that means you have passed apple, banana and cherry, right? So, return type will also be string list. You are trying to print, I mean you are trying to return list of 0. That means the 0th index. What is 0th index? Apple, right? So, the next output I have to get apple, right? So, this is the output I will get. So, when I run the code, right? So, this is the output. Maybe this also we can try in command prompt, and when I go to command prompt, right? So, this code I will be running. So, you can see Python 3 get underscore first element dot py. So, get underscore first element dot py is your Python code, right? So, whatever I have written here, the one you are seeing in the slide, that will be saved as this, and then when you are running the code, you can see you are getting the output 1 and apple, right? So, that is what we are also expecting, and in fact, when I run the code, I got this 1 and apple, right? So, one is an integer list, another one is string list, right? So, this is for your reference. So, how this is working. So, get underscore first element is a generic function, and I have used T as a type variable. So, this type variable, one time it is working as an integer, another time it is working as a string, right? The code reusability. So, I no need to write, that is what the beginning of this particular chapter I explained. So, we will see some of the other cases. So, now we will see container class, alright. So, a container class which is nothing but a generic, right? We call it as a generic class in Python. If you look at the title, right, this is an example. So, the generic container class, right, that is useful to store and retrieve any data type, alright. So, for example, we have already seen from typing you are importing type variable and generic, alright, and then this we have already defined, and the class container, right. Generic is a keyword and the T is the type that you are going to use, and also we had seen the special member function double underscore init double underscore, like star this we have a self pointer over here, alright, which is in fact an instance of a class, and the value, right. So, T integer means it will be integer, if it is a string means it is a string, right. So, then you have self dot value equal to value, this we had already seen the age and name, self dot name equal to name. So, like this you are writing here, and you are having one member function get value. So, self, alright, and then return type is T. So, which is returning self dot value, alright. So, now you have the container, right. So, container and you are passing 1, 2, 3. 1, 2, 3 is what? Integer, correct. So, you have integer container, object is integer container, right. So, when you are passing 123, your generic of T, correct. So, that will be nothing but 123 because it is an integer, correct. So, here you go, when you are having your special member function init. So, whatever value you are passing 123 will be copied into self dot value, alright. So, which is nothing but self dot value, and similarly you have a string underscore container. So, again you are calling the container, but this time you are passing generics in Python, a string you are passing. So, now this capital T will be string now, string underscore container, and the value is nothing but generics in Python, right. So, that will be stored as a self dot value. So, now when you are printing, when in container this object is calling the function get value, get underscore value. So, here you go self dot value initially for the case of integer underscore container, it is 123 will be the output, alright. And the second case string underscore container object, when it is calling or invoking the function get underscore value, you should get generics in Python as the output. This one will be the output. So, when I run the code, alright, so you will get the output like this. So, this you try, right. So, two programs we have done with the help of command prompt. So, what you have to do is a practice, right. So, just find out, right, or just see how I have run the code, and then this I am giving as an exercise kind of, right. So, you try in the command prompt, alright. So, in the previous program, the previous slide, so the container which is nothing but a generic class, and also I told, so this can able to store a value of any data type, all right. And then yeah, as usual, when I am using T, all right, so this is a type variable and this is allowing containers to be more flexible. So, that means it can use different data types. So, generic classes, so that can improve type safety, right, because you are using various types. For example, the last few cases we have seen integer type and a string type like C++ and Java, all right. So, you have type safety and the reusability, all right. So, you may have like in the previous example, one you are wanting for integer, another one you want for string, right. So, that can be handled exactly like what we had seen in Java. So, maybe we will have one more example, all right. So, this is a function to merge two dictionaries with generic keys and values, right. So, as usual we have here we are going to have a dictionary and type variable and k we are using, v we are using. Type variable we are defining k and v. It is like a template class, you define s comma u if you recall in C++, right. So, now I define a function merge underscore dictionaries, all right. So, you use a dictionary, right, you call it as a dictionary 1 and use another dictionary, call it as a dictionary, and return type if you look dictionary k comma v, right. So, it is like adding two complex numbers, C1 is one complex number, C2 another complex number, addition will give you the third complex number. So, here the return type is another dictionary in the form k comma v. So, here this dictionary 1, right. So, let us say it is invoking the copy function, right. So, assume that it is invoking the copy function. So, that means it will start with the first dictionary, it will start with the first dictionary and the result, right. So, you have a result, now result is getting updated with dictionary 2. So, that means the first dictionary will be merged with the second dictionary, all right. So, that is what this program is going to do and then this function will do and it is going to return result, right. So, first dictionary you are copying, second you are updating, all right. So, we can see an example. Here you have dictionary A, you have 1 is apple, right. So, dictionary 1 you have apple and 2 is banana, right. Dictionary B you have 3 cherry, 4 date, right. So, now I am calling this merge dictionaries under the object merge, it is going to return to merge underscore dict, right. You are passing dictionary A and dictionary B, that means 1 apple, 2 banana we are passing. Similarly, 3 cherry, 4 date will be passed, right. So, now when you have this print merge dictionary, all right, merged underscore dict, yeah, because here it is returning when you are calling this merge underscore, you are calling here and then you are passing dictionary underscore A, dictionary underscore B. So, that means it has to return result, correct. So, this result will be stored in merge underscore dict and when you are printing merged underscore dict, right. So, both will be merged, all right. Your merged dictionary will be now 1 apple, 2 banana, 3 cherry and 4 date, right. So, that you will get an output, all right. Maybe we can run this code, okay. So, that in the previous program you will get a confidence. So, here what I am doing, I will just run this code in the command prompt. We will go to the command prompt and then Python 3, the name of this program is merge underscore dictionaries dot python py and you can see the output, right. So, the same code whatever you have used here, the same code if I run, you are getting whatever the output we were expecting, this is the output we get, right. So, here merge underscore dictionaries, right. So, we define that is a generic function. So, that will work with any type, right. So, in fact, with any key and type value. So, here we have more than one type variables k and v, previously we used only t, right. So, here one is the key, another one is value. So, k and v that we are using, one is the key, another one is the value. In fact, the command prompt I told key value, value key type, value type, right. So, we use k and v here. So, this shows, right. So, this particular function shows the Python's flexibility in handling mapping with type safety. In a similar line, So we can see this particular program. So here we are going to use the tuple, right? What do you mean by tuples in Python? So I use from typing, all right. So this will import tuple and type variable. So I am going to use type T, all right. So here I define the generic function swap underscore tuple, all right. So here you have tuple T comma T, all right. So which I am mapping with pair, that means the base address is pair and the return type is tuple TT, right. So what it is returning? So pair, when it is returning tuple TT returns to pair, you will have pair 0, pair 1, etc., right. So whatever the numbers that we are taking. In this case, it is a tuple. So you have 10 comma 20. For example, here in fact I have taken the same example 10 comma 20, right. So what is meant by this? When I am assigning over here, it will get pair of 0 will get 10, pair of 1 is 20, right. So that is the meaning. Okay. So what we are doing here, we are returning pair 1 first and then pair 0, right. So for example, I define integer pair 10 comma 20, right. So when I do this, it will be assigned to pair, that means pair of 0 is 10, pair of 1 is 20. Alright. So now I am returning like form of another tuple. It's like a complex number 1 plus complex number 2. C3 will be another complex number. So I am returning a tuple. So when I am returning a tuple, I want to return first pair 1 and then pair 0. That means swapping. So what is the output? Initially you will get 20, 10. Alright. So that when you call this, right, when I am calling this line number 12, print swap underscore tuple, that is calling the function, you are passing int underscore pair. That means int underscore pair 0 and int underscore pair 1. That will be mapped to, that means base address pair, pair of 0, pair of 1. Already said pair of 0 is 10 and pair of 1 is 20. That is getting swapped. So you will get initially the output this. Second one, you have string pair, hello world, right. So when it goes here, now T is string tuple. You are passing hello, one tuple is hello, another one is world, right. One component is hello, another one is world in the tuple. So pair of 0 is what? Hello. Pair of 1 is world. Okay. So when you are returning this, the other way around you are returning pair 1 and pair 0. That is a tuple. Alright. So when you are calling the function and you are passing this string pair, you have to get the output the other way around, world and hello. Alright. World first, then hello. Okay. So when I run the code, this you can try. Right. When you run the code, you have to get the output like this. Okay. So this is a generic functions with the tuples in Python. Yeah, the same explanation. This is for your reference. Swap underscore tuple is a generic function, right? And then when you are using this generic function, so this has a flexibility of using integer, string or any other data type. In this case, we had seen integers and strings, all right? And the type safety obviously maintained through Python's type hinting. And we have one more function, right? Let us compute the Euclidean distance. What do you mean by Euclidean distance in Python? Right. So here you are importing math. Rest you know, from typing you are importing list and type variable. So here you go, right. So I am going to define a type variable for integer or float, right. So type var T, I put integer comma float, right, and then I define a generic function Euclidean underscore distance. So point 1 list T you are passing, you are mapping to point 1 and another list you are passing map to point 2, all right. So you have x1, y1, x2, y2 and I am asking you to find out the Euclidean distance, right, x2 minus x1 the whole square plus y2 minus y1 the whole square and then you are taking a square root, right. So here the Euclidean distance, it is like the length of the point, right. So suppose I take x1, y1, right, or x1, y1, z1, 3 dimension. Here also it should be x2, y2, z2, right. Otherwise, suppose your input is x1, y1, z1, another one is let us say x2, y2 only, all right. Assume that one is a 3D point, another one is a 2D point, you cannot find any distance, right, that is an error. So you raise the error, right. So what is if a length is not equal? I gave an example, one is a 3 dimension, another one is 2 dimension. So then points must have the same dimension. That means both should be the same dimension. If so, right, if length of point equal to length of point 2, then return the square root of this, all right. So as I said, x2 minus x1 the whole square plus y2 minus y1 the whole square. So if length of point 1 is equal to length of point 2, right. So in that case, so we know that if both the dimensions are equal, Suppose I will take only 2 dimension. So, we know, right, x2 minus x1 the whole square plus y2 minus y1 the whole square and then the square root, right. So, square root of math square root, math dot square root of, so this is a summation, right, plus you have, suppose you have let us say more dimension, alright. So, summation x minus y, so this is your x and this is minus y, okay, x minus y the whole square, right. So, that is what the notation here, and then you are zipping into 0.1 comma 0.2, putting into 0.1 comma 0.2. So, now we will take an example, suppose I have 1 2 3, point A is 1 2 3 integer, point B is 4 5 6, so which is also an integer, and then I am calling the function Euclidean underscore distance, the generic function, passing point A and point B, right, passing two lists, two arrays, point A and point B. So, when I pass this, so it is calculating this Euclidean distance, that is what we have written, alright. So, one array will go as a x, another array will go as a y, alright. So, that is what happening over here when it is finding out the Euclidean distance, alright, and then you are going to get the output. So, first output we are expecting 5.196, and in the second case you can see it is a float, right, point C and point D float. So, I am passing this now Euclidean underscore distance, I am passing point C and point D, right, the same formulation, this time it is a float and we will get the output like this, okay. So, you can check this how it is working, you can check this, in fact 0.5 only we incremented in all the cases, right. So, both should be same, right, when you are subtracting, let us say 4.5 minus 3, 5.5 minus 2.5 3, 6.5 minus 3.5 3, okay. So, both you have to get the same output. So, this also you can try. So, in fact, we can get the output like this when you run the code, right. So, this is the complete explanation how the generic functions are like the previous example. So, this is for your reference, you can just go through that. So, whatever I have explained in the previous slides, so each and every modules, so I have given as a explanation over here. So, the conclusion point of view, so when we are using C++, we use template, right, when we use C++, it was template, right. So, in the case of Java and Python, we call it as generics, all right. So, in the case of C++, we have already seen it is a compile time generic programming and it is highly flexible, but it is lacking the strict type safety, all right. So, when you are using integer or double or float, there is some, right, I mean in fact, it is lacking strict type safety. So, the templates can lead to larger binaries. So, this we had seen in fact, when we are talking about, right, so converting and then the reconstruction if you recall, right. So, the binaries, right. So, because of due to separate instantiation for every data type, right. So, this is about C++ template. So, whereas in the case of Java, you have the strict type safety, all right. So, the compilation time it is checking the type safety, but it is limited by type arrays, all right. So, in fact, when we talked about the Java generics, we had seen these properties and also it requires the bounded types, correct, and wildcards to support complex generic types. So, these are all we had already seen in the case of C++ and template, and in the last few lectures, right. So, we talked about this Python generic, all right. So, this is the improved readability, right. So, only thing you have to practice, those who are learning first time Python, you practice the initial code and then when you are coming to the generics, so you can find the beauty of this particular interpreter, right. So, therefore, when you have the improved readability and this is enforcing generics, but Python remains dynamically typed, right. So, whereas we had seen in the case of a C++, it is compile time, right. So, since that is the compile time, so here it is offering runtime flexibility, right. Python is having the runtime flexibility and it is easy to use. In fact, when you are writing the code in Python, you can find it very, I mean easy compared to Java and C++. So, when you are adding this generics concept, right. So, in fact, I mean you can have the flexibility, right. So, whether it is a runtime or you can see the easiness, right. So, this is all about your the templates and generics. So, in fact, in this chapter, I introduce Python as well, right. So, we have extensively studied C++, Java, and in fact, we had seen several examples with the help of C++ and Java. So, now from this chapter, what you can do, you try to write the simple code, right. So, till let us say loop, and then see how you have to write, almost same, all right, but only thing the syntax will change for classes and objects. So, once you are familiar, then you start trying to use the concept of generics in Python, right. So, with this I am concluding this chapter. Thank you all.